Open the cabinet under your kitchen sink. Look at the filter sitting in that plastic pitcher. There is a date on the cartridge. It is probably expired. You have been meaning to replace it. You have not. And every glass of water you have poured through it since that date may be dirtier than what comes straight out of your tap. That is not a scare tactic. That is the finding of a peer-reviewed study out of Duke University. Researchers tested filters in real homes across North Carolina. Not in a lab, in kitchens like yours. The pitcher filters, the Brita, the PUR, showed wildly inconsistent results for removing PFAS, the forever chemicals now found in the blood of nearly every living person. Some of those filters removed nothing, literally zero measurable reduction. And the whole house systems, 4 out of 6 tested showed PFAS levels that were higher after the water passed through the filter. The saturated carbon inside had trapped all it could hold. Then it started leaking those chemicals back into the water. Your filter was not cleaning your water. It was storing poison and slowly releasing it into every glass you drank. 172 million Americans drink PFAS-contaminated water right now. The EPA has known about this for years. They delayed setting enforceable limits. And the product sitting on your counter was never engineered to solve this problem. It was engineered to make you feel like you were doing something about it. 2,000 years ago, a Roman engineer named Frontinus managed the water supply for over 1 million people. No electricity, no cartridges, no subscriptions. His system ran for 500 years. And the reason you have never heard of it has nothing to do with science. Here is what a water filter actually is. Not what it does, what it is as a business. The global replacement cartridge market is worth over $19 billion. Not the filters, just the part you throw away. The business model is the same one that sells you razor blades and printer ink. Sell the hardware cheap. Lock the customer into proprietary refills. Collect recurring revenue until they die or switch brands. Proprietary cartridges are marked up as much as 400% over generic alternatives. Manufacturers design housings that only accept one specific cartridge shape so you cannot shop around. Newer digital systems include built-in expiration timers and app notifications that tell you to reorder on a schedule the company sets, not one based on your actual water quality. And the whole industry is sprinting towards subscriptions. Market analysts describe it plainly. Companies that convert 20% of their customers to auto-ship cartridge programs can boost recurring revenue by 30 to 40%. They call this the key growth frontier. Your filter is not a health product. It is a razor blade with a health label on it. And here is the cruel part. The Duke researchers found that the only home filters that actually worked against PFAS were under-sink reverse osmosis and 2-stage systems. Those reduced contamination by 94% or more, but they cost hundreds of dollars. The researchers themselves warned that this creates an environmental justice problem. The communities most poisoned by PFAS are the ones least able to afford the only filters that work. So the cheap option fails. The effective option is too expensive for the people who need it most. And every 60 days, another cartridge ships. What if the solution was not a product at all? What if it was infrastructure? The Romans started with something no filter company will ever sell you. They started with better water. Roman engineers did not grab the nearest river and try to clean it up downstream. Rivers were polluted even then. Agriculture, tanning, sewage, all of it ran into open waterways. Instead, they sent surveyors into the mountains to find springs, clean water at the origin, sometimes 50 miles from the city, sometimes further. The quality of the source was the first and most important stage of purification. Get this right, and every stage after it works better. This was documented obsessively. The architect Vitruvius wrote evaluation criteria for water sources. The naturalist Pliny the Elder cataloged water types by taste, clarity, and health effects. And Frontinus, once he became curator aquarum, commissioner of Rome's water supply, graded every single aqueduct feeding the city. He did not just test the water, he ranked it. He assigned grades. He published the results in an official report to the emperor. Some aqueducts carried water pure enough for drinking. Some were designated for bathing. One specific aqueduct supplied water for filling arena pools where they staged mock naval battles. Not a drop was wasted on the wrong purpose. Different water for different jobs, every source accounted for. Here is the concept modern systems have almost entirely abandoned. The Romans separated water by quality before it ever reached the city. They treated source selection as the foundation of the entire system, not an afterthought. Your tap water and your toilet use the same pipe, the same treatment, the same grade. Frontinus would have called that engineering malpractice. Now the water has to travel. 50 miles of terrain between a mountain spring and a city of 1 million people. No pumps, no pressure tanks, no electricity. One force moved the entire system: gravity. Roman engineers carried 2 tools. The corrubates, a large wooden frame with a water level cut into the top, measured slope. The groma, a vertical pole with weighted strings hanging from a crossbar, handled alignment. No lasers, no GPS, no digital surveying equipment, just wood, water, and string. With these 2 instruments, they achieved a consistent, barely perceptible downhill grade maintained across tens of miles of rock, soil, and valley crossings. We are talking about slopes so subtle that you could walk the entire length and never feel like you were going downhill. But the water felt it. It entered at the source and arrived in the city days later, having flowed the entire distance under its own weight. Most people picture the grand arched bridges when they think of Roman aqueducts. Those exist, they are extraordinary, but they are the exception, built only where the terrain dropped away and no other option worked. The vast majority of the system was underground tunnels, carved through rock, lined with waterproof cement the Romans adopted from the Punic world. Tunnels were cheaper, harder to sabotage, and shielded the water from sunlight and surface contamination. They were also built large enough for a grown man to walk through, because the Romans did not build anything they could not maintain. They sent inspectors into the tunnels on a regular rotation. These workers were called circuitors, line walkers. Their job was to check for cracks, leaks, and mineral buildup along every mile of channel. If something broke, a crew fixed it. If scale accumulated on the walls, workers scraped it off by hand. Maintenance was not something that happened when the system failed. It was scheduled. It was staffed. It was built into the design from the first day. No modern filter company sends someone to check whether your cartridge is actually working. The Romans checked their system by hand, on foot, in the dark, inside a tunnel, every week. Now the water treatment begins. And this is where the elegance of the Roman approach becomes clear. At the head of each aqueduct, before the water entered the main tunnel, the Romans constructed multi-chamber basins called piscinae limariae. These are settling tanks. The principle behind them is one of the oldest and most reliable methods of water purification ever devised. Fast-moving water carries particles, silt, clay, organic debris, anything light enough to stay suspended in a current. But when that water enters a wide, deep basin, it slows down. And when it slows down, gravity takes over. The heavy particles sink, the water moves to the next chamber through an opening set higher than the floor, so only the cleaner upper layer passes through. It slows further. Finer particles drop out. Chamber by chamber, the water gets clearer. By the final basin, the visible sediment is gone. The floors of these tanks were sloped. When it was time to clean, workers drained the basin and scraped the accumulated sludge off the bottom. Then the system went right back into service. No parts to order. No cartridge to swap. No proprietary shape that only fits one brand. The physics of settling did the work, and the stone basin lasted as long as anyone cared to maintain it. The Romans understood that turbidity, cloudiness caused by suspended solids, was not just an appearance problem. Those particles could settle inside the aqueduct channels themselves, silting up the flow and eventually blocking the system. The piscinae limariae solved this at the very start of the line. Clean the water early, and the entire downstream infrastructure runs longer with less maintenance. That is preventive engineering. That is designing a system around durability rather than replacement. Think of a carbon filter as a sponge. It absorbs contaminants until it is saturated. After that, it cannot hold any more. Squeeze it and the dirty water comes right back out. That is not a metaphor. That is exactly what the Duke researchers documented. Filters passed their useful life, releasing captured PFAS back into the drinking supply. Now think of a piscina limaria as a bathtub with a drain plug. The dirt falls to the bottom. You pull the plug, you rinse, you start again. One system is designed to be thrown away. The other is designed to be cleaned. The difference between those two designs is not about technology. It is about who profits. Now, to be clear, a settling tank does not remove dissolved chemicals. It does not kill bacteria. It does not strip pharmaceuticals or industrial solvents from the water. The Romans knew this too, which is why they did not rely on one single stage. Settling was the first step, aeration was the second, source selection was the foundation underneath both. And each stage handled what the others could not. That layered approach is the reason the system worked. It is also the reason a single carbon cartridge in a plastic pitcher does not. Along the length of every aqueduct, at regular intervals, the Romans built vertical shafts from the tunnel up to the surface. They called them lumina or columnaria. From the outside, they looked like stone chimneys dotting the landscape along the aqueduct route. They served two purposes, and both of them mattered. The first was access. A tunnel that runs for miles underground is useless if you cannot get inside it when something goes wrong. The shafts let the circuitors enter and exit the system without walking back to the origin point. The second was something the Romans described but could not fully explain. They observed that water flowing through ventilated tunnels tasted better, looked clearer, and caused fewer problems than water from sealed conduits. Frontinus noted this in his report to Emperor Trajan and specifically cited air exposure as a benefit. The Romans knew about siphons. A siphon is a sealed pipe that dips down into a valley and rises back up the other side, using pressure to move water across a depression. It is cheaper than building an arched bridge, but it is sealed. No air gets in, no inspector can enter to clean it, and the water that came out of siphons was noticeably worse than water that had traveled through ventilated tunnels. The Romans noticed this, and they chose the more expensive option because the water was better. They built fewer than a dozen siphon systems in the entire empire. They built thousands of ventilated tunnel sections. Modern chemistry explains why they were right. When water contacts air, dissolved metals like iron and manganese oxidize. They shift from an invisible dissolved state to solid particles that can settle out or be filtered. Aeration also strips dissolved gases that cause off tastes and odors. And it raises oxygen levels in the water, which suppresses anaerobic microorganisms, the kind that thrive in stagnant, oxygen-poor environments and make people sick. The Romans did not know what bacteria were. They had no microscopes. They had no periodic table. But they ran a controlled observation across dozens of aqueducts over hundreds of years, and they concluded that ventilated water was safer. So they built ventilation into every system as standard practice. Every municipal water treatment plant on Earth uses aeration today. The Romans were doing it with a hole in the ceiling of a tunnel. When the water reached the city, it arrived at a structure called the Castellum Aquae, the water castle. This was the central distribution point where a single aqueduct line was divided into multiple channels feeding different neighborhoods, public fountains, baths, and private connections. Frontinus managed this system directly. His title was Curator Aquarum, and he reported to Emperor Trajan. He wrote a detailed technical report on the entire water network called De Aqueductibus Urbis Romae. In it, he documented flow rates, source quality, distribution allocations, and the organizational structure of the teams who maintained it all. At its peak, Rome operated 11 aqueducts simultaneously. Together, they delivered roughly 1 million cubic meters of water per day. That is around 264 million gallons every day. To a city of over 1 million people. Powered entirely by slope. No other civilization would match this scale of water infrastructure for more than 1,000 years after Rome collapsed. The administration behind this was enormous. Specialized officials oversaw policy. Engineers designed expansions and repairs. Architects managed construction. Laborers and dedicated crews handled daily maintenance on rotating schedules. Water was not a side project. It was treated with the same institutional seriousness as the military or the road network. The streets were lined with public stone fountains, simple rectangular basins with a pillar spout, offering free, clean water to anyone who passed. Private connections existed for the wealthy, but public access was the baseline. Water was a civic right, not a product on a shelf. This system operated for roughly 500 years. Here is the part that should reframe everything you have heard so far. Walk into your nearest municipal water treatment plant. You will find settling basins where suspended solids drop out of the water, aeration towers where water is sprayed or cascaded through open air, sand and gravel filtration beds that catch remaining particles, multi-stage processing with trained operators monitoring output quality around the clock. That is the Roman method, refined, scaled, and automated, but structurally identical: settling, aeration, filtration, monitoring. The first modern large-scale version of this system was built in 1804 by a Scottish engineer named John Gibb. He needed clean water for his textile bleaching plant in Paisley. His design passed water from a stone-filled channel into a settling basin, then through a gravel filter, then a sand filter, and finally into a central storage reservoir. Settling, filtration, storage. That sequence is a direct echo of the Roman approach. Gibb was not reinventing water treatment. He was rediscovering what Frontinus had documented 18 centuries earlier. And that basic sequence is still the backbone of every water treatment plant in the industrialized world. Your city already runs this system. Professional engineers oversee it. Regulators test the output. Published water quality reports document the results. Multiple redundant stages catch what any single stage might miss. Your Brita pitcher attempts to replicate that entire process with one small carbon cartridge inside a plastic jug. No settling, no aeration, no multi-stage filtration, no testing of the output. No accountability. You pour water in, you pour water out, and you trust a consumer product to do the job of an entire municipal facility. Nobody is checking what comes out of your pitcher. Not the manufacturer, not the government, not you. The Romans had a full-time water commissioner, published engineering reports, quality grading by source, and inspectors walking the tunnels every week. Your 60-day cartridge has less oversight than a Roman hole in the ground. If your city already purifies your water using the method Frontinus designed 2,000 years ago, then what exactly is the cartridge for? When Rome fell, its water infrastructure collapsed with it. Europe went dark for 1,000 years. Cities drew water from open wells and contaminated rivers. Typhoid and cholera killed in waves. Nobody connected the outbreaks to the water because the prevailing theory of disease was miasma, the idea that sickness traveled through foul air. Even after the invention of the microscope, even after a Dutch tradesman named Leeuwenhoek peered through a lens and saw microorganisms teeming in a droplet of water, the authorities did nothing. They had the evidence. They had the technology to observe it, and they still let people drink from the same rivers they dumped sewage into. The infrastructure Frontinus had built was buried, broken, and forgotten. 1,000 years of cholera was the price. Clean water only came back when industry needed it. Textile mills, bleaching plants, and paper factories required enormous volumes of purified water. The solutions that followed were commercial, not civic. And once the Industrial Revolution produced a consumer class, water filtration became a product category. That is when the model flipped. Frontinus treated water as a public obligation. He reported to the emperor. His system was funded by the state and maintained by government employees. Access was universal. The modern filter industry treats water anxiety as a revenue opportunity. The residential filtration parts and accessories market was valued at $9.5 billion in 2023. It is projected to hit nearly $14 billion by 2029. Industry analysts openly describe cartridge replacement as recurring income streams. Companies compete by building what reports call after-sales service and spare part ecosystems to secure recurring revenue. The growth strategy is not better filtration, it is stickier subscriptions. You cannot sell a subscription to a stone-settling basin. You cannot auto-ship a gravity-fed aqueduct. There is no recurring revenue in a system that lasts 500 years without a single replacement part. So that system was left in the ground, and in its place you were given a plastic pitcher with a timer on the cartridge. The Roman method was not replaced because it stopped working. Your own city's water plant proves it works every single day. It was abandoned because it could not be monetized. Frontinus published his methods. He graded his sources. He staffed his system with people who walked the tunnels in the dark to make sure the water was right. His infrastructure ran for centuries after he died. When something broke, his crews repaired the stone. They did not order a replacement part from an app. They did not wait for a notification. They walked the line, found the problem, and fixed it with their hands. You are spending $9 every 60 days on a cartridge that may not remove the contaminants that actually threaten your health. If you forget to swap it on schedule, it poisons your water with the chemicals it previously captured. And no one tests the output. No one checks. No one is accountable. You are trusting your family's health to a product that was designed around a billing cycle, not a safety standard. The Romans built a system that served 1 million people for 500 years with nothing but gravity, stone, and institutional willpower. You are trusting a plastic pitcher that expires in 2 months, 500 years, 60 days. One of these systems was designed to last. The other was designed to be replaced. You already know which one you are paying for.